Thank you for joining me here this morning. We are here today to talk to you about resistive potential divider under the guidance of Mrs. Dhain ma'am. Now let's see the topics that we will cover in this presentation. Starting off, we will see why do we need resistive potential divider. Then its circuit diagram, construction. After that, its operation with example. Subsequently, we will move towards its usefulness, merits and demerits. Voltage dividers are one of the most fundamental circuits in electronics. A voltage divider is a simple circuit which turns a large voltage into a smaller one. Using just two series resistors and an input voltage, we can create an output voltage that is a fraction of the input. A simple example of a voltage divider is two resistors connected in series with the input voltage applied across the resistor pair and the output voltage emerging from the connection between them. Resistor voltage dividers are commonly used to create reference voltages or to reduce the magnitude of a voltage so it can be measured, and may also be used as a signal attenuators at low frequencies. Resistive potential divider is basically a method to measure high DC voltage.
Methods of measurement of high DC voltage. There are mainly four methods for the measurement of high DC voltage. First one is series resistance microammeter method. Second one is resistance potential divider method. Third one is generating voltmeters. And last one is spear gap method. So among these we are going to see about resistance potential divider method. Next one is why we need resistive potential divider, that is resistive potential divider need. Potential divider is a passive linear circuit that produces an output voltage that is a fraction of its input voltage. So that's why to avoid high loading of resistance R, another resistor is added. Then when high precision is needed, resistive potential divider method is used. Then there is also advantage that simplicity of construction, less space requirement and less weight and easy portability. So resistive potential divider we needed. Here is a one example of resistive potential divider method. Circuit diagram is shown. Resistor R1 and resistor R2. That is, these two resistors are connected in series with each other. Here is a high voltage, and when there is a sudden change in voltage, such as due to the switching operations, flashover of the test objects or any short circuit, damage may occur to the divider element due to stray capacitance and ground capacitance across the element. These can be avoided by controlling the capacitance across the element. These capacitors across the elements. Due to voltage divider arrangement, the influence of temperature and voltage can be eliminated. Corona-free termination is done to avoid unnecessary discharge at high voltage ends. At 100 kV accuracy is up to minus 0.05%, and in a 300 or 500 kV accuracy is about 0.1% to 0.5%. So that was the construction of this circuit diagram, and here is the resistive diagram, and capacitance are connected across them.
Hello everyone. As of now, we have seen the theory regarding resistive potential divider along with the circuit diagram and the construction of it. So now let's focus on the operation of the resistive potential divider. The circuit consists of the high voltage resistance R1 and R2. As we seen in the circuit diagram, we have two resistance R1 and R2. A delay cable is also with it, a surge impedance Z, and the deflecting plates of CR1, which is nothing but the cathode ray oscilloscope. The extra resistance may also be connected either in series with the delay cable or across the deflecting plates. The resistance are so important from the impedance matching point of view so as to obtain the given wave shape. As we know, the wave shape is to be corrected. So the final result should be V1 upon V2 equal to R1 upon R2. So now let's check upon the example of simple resistive voltage divider. As you can see the circuit diagram, it consists of resistance R1, R2 and voltages in V1 and Vout. So in the resistive divider, we can choose our both impedance Z1 and Z2 to be a purely resistive R1 and R2. So from the given expression, we can get V output as R2 upon R1 plus R2 into V in. If we check our R1 and R2 to be equal, then our V output would be half of V input. That which is nothing but our voltage divider is divided into the two equal resistances. It will also going to give you a two different voltage, two equal voltages. So if you choose the most common voltages used, which are nothing but V output is 6 voltage and V in as the 9 voltage, then by the formula you can get R2 upon R1 plus R2 to be 2 by 3. And by solving this using a simple algebra, our R2 value which we gain from this expression would be R1 equal to R2 into V in upon V out minus R2. And if you solve this for the R2, our value for the R2 becomes R1 into 1 upon V in minus V out minus 1. So as you can see, any ratio V out upon V in is not greater than 1. That is, using the resistance alone, it is not possible to invert this R1 upon R2.
Now, the usefulness of the resistor voltage driver. Resistor voltage driver are commonly used to create the reference voltage or to reduce the magnitude of the voltage. So it can be measured and may also used as the signal attenuators and at the low frequencies. For the direct current and relatively low frequencies, a voltage driver may be sufficiently accurate if it made of resistor, where frequency response over a wide range is required, such as oscilloscope. A voltage driver may have capacitive element added to compensate the load capacitance. In electric power transmission, a capacitive voltage driver is used to transmit or used to measurement of the high voltage. Now, merits and demerits of the resistive potential driver. The merit of the resistive potential driver are it is very less in the weight and where its probability is so easy, it can be placed near to the test object and maintain the simplicity of the connection. And mainly, it require very little space. Now, in this parallel universe, every merits have the demerits. Now, the demerits of the resistive potential driver are the resistive value R causes the power loss and the outside voltage distorted for the high frequency, and it required the very careful electrostatic shield to minimize the stray capacitance of effect. Thank you.